All right, so today we're doing our third different solving systems. We did graphing the first day, we did substitution last class, and today we're doing linear systems by combination or elimination. You'll hear me call it mostly elimination, but I'll use the word combination a lot, especially when we're talking about what we're doing, is combining sentences here. So linear combination / elimination, we want to combine the equations to eliminate one of the variables. This is where it comes from. So we're either combining two of the two equations, and we're going to eliminate, we're going to get rid of one of the variables, either x or y. So our basic steps here are step one, line up the equations. And what we mean by that is you're going to line up like terms. Your x's are all going to be, one on top of the other. Your y's will be on top of each other. Your equal signs will be in the same place, and your numbers. So we want something that's very, very simple. For example, like 2x plus 3y equals 7, and then 5x minus 2y equals 10. That's a line. That's what we want. That's good. That's what we mean by lined up. Versus, say we had like 2x plus 3y equals 7 again, and then we had, I'll use the same thing, 5x equals 2y plus 10. You'll notice my equal signs are different. Even though the numbers and the variables are all lined up where they're supposed to be, the equal signs are not. So that's a no. That's not lined up. We'd have to change things. Same system, but not in alignment. So we want the first way, not the second way. We want to line them up, equal signs, x's and y's all lined up. And again, it doesn't have to be exactly that order, but that's typically what we're going to do. Standard form is what we want. Step two is we're going to combine like terms vertically. So this is why we stack them like this. We want them to be lined nicely. And what we're going to accomplish here is we're going to eliminate one of the variables, either x or y. Now, what we're going to have to do is you may have to multiply one or both equations to achieve the elimination, to be able to do the eliminating of one of the variables. So we may have to multiply one or both equations. So I'm going to put that in there. Once we're able to do that and eliminate one of the variables, we go to step three and we solve for the remaining variable. So if we wanted to get rid of the y's, we cancel out the y's at that point, and we'd have something x equals a number, solve for x. Basically divide and solve for x. Once you do that, we do what we've done every step of the way from substitution, which is you take that number, plug it back into the original equations, and we solve for the remaining one. So if we found x, we will solve for y. If we found y, we'll solve for x. All right, so here's an example. We want to solve this system. So 10x plus 5y equals 0, negative 10x minus 9y equals 8. So what we're going to do is we want to just kind of rewrite these, stack one over the other. So I'm going to take 10x plus 5y equals 0, and minus 10x minus 9y equals 8. And so, all right, I look at that and I go, all right, numbers are in the right place, variables in the right place, the equal signs in the right place. We're good there. And we notice that 10 minus 10x, if we combine those, we're going to eliminate the x's. They're going to go away. So what I'm going to do is we're just going to add these two equations together. We're going to just add them together. 10x minus 10x, cancel out. That's a 0. Get rid of them. 5y minus 9y, well, that's minus 4y equals 0 plus 8, which is 8. We've eliminated the x's. All we have left is y. We just solve for y at this point. Divide by negative 4, and we get y equals negative 2. So we got half my answer. All right. We have half my answer. We have y equals negative 2. We just got to solve for x. Now we can plug it back into either equation. I'm going to choose the first one. Just looks easier to me to do. 10x plus 5 times negative 2 equals 0. 10x minus 10 equals 0. Move the 10 over, negative 10 over. It becomes 10x equals 10. So x equals 1. And remember, when we do write our x and y, when we get a solving, we always put it as a coordinate pair. So 1, comma, negative 2. All right, let's look at the next one here. 8x plus 6y equals negative 10. 5x plus 6y equals 14. All right, so again, let's rewrite this stack together. All right, so we see here that, yeah, variables, numbers all lined up, great. However, we can't eliminate anything because we're thinking y right now, which is what we should be doing. But we can't eliminate them because they're both positive. We add them together, it's 12, not 0. So we have to get rid of one. So we have to make one the opposite. That's why we say we have to multiply. So what we really have to do is we're going to take the second one, and I'm just going to multiply everything by -1. So I'm just going to completely rewrite this again as 8x plus 6y equals 10, and I'm going to rewrite the second one as -5x minus 6y equals -14. All right. Combine like terms, combine the sentences. 8x minus 5x is 3x. 6y minus 6y is 0. And that should be -10, not +10, sorry. And then -10 minus 14 is -24. And so we divide by 3, and we get x equals -8. And then, of course, now we just take that and plug it back into either of the originals. Let's plug it back into the second one. 5 times -8 plus 6y equals 14. -40 plus 6y equals 14. 6y equals 54. So y equals 9 at this point. So again, -8, comma 9. Let's do a couple more. So what happens if we do not have the same coefficients? What happens if they're not easy to see? So let's look at the first one. We have 4x minus 12y equals 28. -2x minus 4y equals 26. In any case, we can choose which variable we want to eliminate. If you want to eliminate x, let's eliminate x. If you want to eliminate y, you can eliminate y. It's just your choice. I would choose the x in this one because 1, 4, and 2, very easy. I know the bottom one, just double it, and we get to 4. And the other one is that they're already opposite signs of each other. 4 is positive, and there's a -2 below it. So I think that would be the easier one. I'm just going to multiply the bottom one by 2. So let's rewrite them. 4x minus 12y equals 28. Minus 4x minus 8y equals 52. Now we combine them. 4x minus 4x is 0. -12 minus 8 is -20y. And that is equal to 80. So now in this case, y equals -4. And voila, we got our answer. Y is -4. Now we can just solve for x, plug it back into any of the equations. Let's go with the first one here. 4x minus 12 times -4 equals 28. 4x plus 48 equals 28. 4x equals -20. X equals -5. So my answer here is -5, comma, -4. All right, let's look at the second one here. Second one, 8x minus 3y equals 15, and -6x plus 10y equals 12. Now, again, we can choose x's or y's. I'm going to do y's this time just because we did x's last time. 3 and 10, least common multiple, that's where we're going with this, would be 30. So we're going to multiply the top one. In this case, we're multiplying both equations, the top one by 10 and the bottom one by 3. So we need not to multiply by a negative because they're both one's positive, one's negative. We could have done x's. If you did the x's, 8 and 6, least common multiple would have been 24. It still would have been acceptable. All right, so multiply the top one. You get 80x minus 30y equals 150. And then you get -18x plus 30y equals 36. Combine them, eliminate the y's, and we get 62x equals 186. And if you divide both sides by 62, x equals 3. So that comes up very nicely. All right, again, plug it into any of them. I'm going to plug it into the second one, or the first one. 8x minus 3 times 3 equals 15. 8x minus 9 equals 15. 8x equals 24, so x here is 3. Oops, I did that wrong. My bad. I had X. I'm trying to solve for Y. Sorry. 8 times 3 minus 3y equals 15. My bad on that one. 24 minus 3y equals 15. Negative 3y equals negative 9. Y ends up being 3. So it's still 3 and 3. I just solved the wrong one in that case. So 3, 3 would be my answer on that one. All right, so now what happens if they're not aligned very easily? Well, what do we think? We got to make them align. So normally we want the x and y's on one side, numbers on the other. That's typically what we do. So for the first one, I'm going to subtract 2y from both sides. Gives me negative 7x minus 2y equals 4. And over here, I would just add 1. And so what I'm going to do is I'm just going to go ahead and take this and move it over here and give me 8x plus 6y equals 1. And what we'll notice here is that, again, we can choose either x and y's, but I'm thinking y's are the best one because negative 2 goes into 6 pretty quickly. I'm going to multiply the top one by 3. So negative 21x minus 6y equals 12. 8x plus 6y equals 1. Y's cancel out. You get negative 13x equals 13. So x equals negative 1. Makes that nice. And then again, I can plug them back. I can plug them into the 2 I solved for or the originals. Does not matter. I'm going to plug it into the 8x plus 6y. 8 times negative 1 plus 6y equals 1. Negative 8 plus 6y equals 1. 6y now equals 9. Divide both by 6. So y equals 9 over 6, which reduces to 3 over 2. So, of course, my answer as a coordinate would be negative 1, comma, 3 halves. All right, now what happens if we have fractions? Everyone's favorite, right? You can do it the same way we've been doing it. Find opposites, do that. The problem is a lot of times we don't like fractions. We don't like looking at them. They can be very difficult, especially if there's multiple different denominators. Everything would be great if the very last one over here, this 5 halves, actually had a 3 on the denominator. That would work better, but it doesn't. So let's clear the fractions. The first one, because all the denominators are 3, we know the least common number is 3, so we'll multiply everything by 3, and we get 2x plus y equals 2. And that looks a lot easier to solve. Second one, the least common denominator is 6, 3 and 2. So we get 2y plus 2x equals, in this case, 15. 6 times 5 halves is 15. All right, so let's go ahead and stack these up and put them in order. So we're going to write it out as 2x plus y equals 2 and 2x plus 2y equals 15. Now we got to figure out what variable we want to get rid of. And I'm going to tell you right now, x's are probably the best because they're both the same. We don't really have to do anything other than make one of the negative, and I'm going to make the top one the minus. Just because I'm going to get a positive y if I do this. You can do it either way. It doesn't matter. But this one just, I think, is going to be a little easier on us to see. So negative 2x minus y equals 2. And 2x plus 2y equals 15. You add them together, the x's eliminate. 2y minus y is just y. Negative 2 there. And 15 minus 2 is 13. Y is 13. Now we just solve for x. I'll plug it back into the first one. 2x plus 13 equals 2. 2x equals negative 11. X equals negative 11 over 2. And we still end up with a fraction as an answer, but not as bad to solve. Negative 11 over 2, comma, 13. All right, so last but not least, we have word problems, all right? We have to deal with the word problems. They are going to be there. Just got to remember how to do them. Remember, typically word problems, they deal with values and totals, or if you're dealing with the same 2 variables, which is the other scenario, they may be used the same amount in 2 different ways. So let's look at the first one. The band sells cans of popcorn for $5 per can and mixed nuts for $8 per can. The band sells a total of 240 cans and receives a total of $1,614. Find the number of cans of popcorn and mixed nuts. So let's think about it. P, I'm going to use P for popcorn. Pretty obvious. And I'm going to use M for the mixed nuts. Or you could use N for nuts. Either way, I'm going to use P and M. All right, so thinking my first one, P and M, we don't know how many popcorn cans, we don't know how many mixed nut cans, but we know we sold a total of 240 cans. So P plus M equals 240. That's going to be my first equation. And then my second equation is going to be my value one, and I know it's $5 for every popcorn plus $8 for every mixed nuts is now equal to 1,614. Now, beforehand, we did substitution. We'd solve for P or M and then plug it in and do all the multiplication. This is kind of where I like elimination. I don't really have to do that much with this. Other than I need to get one of these to be opposite. You can choose either of them. I think P is going to be the easiest because it's 5. I'm going to multiply the top one here by -5. So by doing that, I get -5P minus 5M equals -1,200. With 5P plus 8M equals 1,614. Combine them. P's cancel out. You get 3M equals 414. Divide both by 3. And M here equals 138. So 138 cans of mixed nuts. All we have to do now is find how many popcorn, and we just plug it back in. I'm going to plug it into the first one. I think that's the easy one. P plus 138 equals 240. So P here equals 102. So 102 cans of popcorn and 138 cans of mixed nuts. All right, so just remember you have a quiz next class, and definitely be prepared.